I am Mark Shields. I'm the plant electrician for O.P. Schumann & Sons in Warrenton, Pennsylvania. This is a very large facility. It was just liquidated in June, and all of its assets were auctioned off. A lot of items are left behind. The building was purchased by a company that's going to be moving in as soon as settlement is done. It is August. The auction was held in June. I have personally disconnected over 200 machines, most of which were CNC, large CNC type machines, and a lot of smaller types of machinery as well. It's been a very intensive job, but everything has been done safely and according to the National Electric Code, which I have been required, particularly pay attention to certain items related to the agreement of sale between the two parties. So the following video will have a quick little variety of areas that I work in to show you the plant a little bit before it's taken over by the new company. Thank you and enjoy the information. Okay, this cutout switch is still energized. We're going to disconnect this. There's construction going to be going on pretty soon. We don't need this energized out here. About 120 feet away is a 225 kVA transformer supplying it, and a couple other boxes like this one. We're going to cut that transformer out by turning off a 400 amp circuit breaker in the distribution room near it. That'll make all of these areas much safer to work on. So this is the fourth section over, known as the boring mill. This area had several very large CNC machines. There's the residual footprint of the machine. And here you have a transformer converting, stepping down 480 to 240, 120. And that 120 is being provided to that panel there and also to that 240. So this area is nice and neat. This was the supply for all the large machines. That was a Lucas boring mill right there in those pits. And I was just standing over there. Several other boring mills. We have 2 overhead cranes in this location. Lighting, outlets. So all this is very neatly terminated. All the electrical terminations and disconnections were all made by me personally. Everything was done in a safe manner and everything is looking very neat. Okay, this is my air compressor station. 2 Atlas Copco GA55 screw type compressors equating to 55 kilowatts of usage. Each one of these. The B one there is newer and this is the older unit. They're approximately the same, although this older unit tends to sustain better CFM for some reason, although they're rated the same. They're a sequencer, Atlas Copco sequencer, sequences them according to demand. There's 4 possibilities to program that. And down here we have a very nice Intermatic 365-day timer. Very nice. A lot of capability. Intermittent stops and starts. Can adjust for sunset, sunrise in different geographical zones. Daylight saving. Really a lot of capability. 2 relays there. In this case, that left relay is controlling A and B compressor, and the second relay to the right controls the air dryer, air cooler, air dryer. So over here is our holding tank. There's our air dryer. There's some control apparatus. This is a hoist crane that somebody parked in the wrong position. So we can start this up. Okay. Come over here and start our compressor up. We can start these manually. Stop that. Okay. That just shows you I have manual control over the system. We're not on automatic timer anymore because there's just a small skeleton crew working. But I keep this second compressor running so we have compressed air. When I start it up, it will charge this tank and give us air for most of the day with just that tank. So I have most of the shop closed off through this valve, sections 3 and 4, and down there's some other valves that close off the other sections. Okay, and that's it. That's a very nice setup, and it performs wonderfully. It'll stay running automatically according to demand requirements that is input by myself, and great machines. Okay, there's a nice gas heating unit. Coming over here to some boxes that I'm tidying up. This is the last room of electrical terminations. This was a Bridgeport machine here and over there. As you can see, two different color tapes. I like having different color for each voltage. The yellow in this case being 240 and the red being 120 volts passing through the same box. So that helps me out and helps the next guy out. Okay, back to this Bridgeport. Another good feature about this. Let's turn this on. Going rather fast. Let's slow this thing down. That's better. Alright, the variable speed here is a very good feature because you could put a piece of stainless steel in there. I would put it in faster and then slow down until it starts cutting. And other uses, of course, so that's a good feature. In this presentation today, I would like to resolve an issue that comes up from time to time concerning the language of the machinist. Primarily the concept of tenths, which is quite often misunderstood. But let's start with the basic division that a machinist would use in a machine shop or laboratory. Now take an inch and divide it into 1,000 subsections. Okay, imagine 1,000 of these going across. Okay, each one of those would be 1/1000th of an inch, a thousandth of an inch, or 0.001, or 1 part in 1,000. Okay, now the tenth, the misunderstood tenth. Take one division, or 1/1000th of an inch, divide that one section, or one division, into 10 parts. One of those 10 parts is a tenth of an inch, or 0.0001, or 1 part in 10,000. Okay, very simple concept. So that's a machinist tenth. What a machinist refers to as a tenth. Okay, now the millionth of an inch. Okay, now take one of those tenths down here and divide that into 100 divisions. Okay, you'll have 5 zeros there, 0.000001, or 1 in 1 million. That's a millionth of an inch. Okay, a millionth of an inch, by the way, is not to be confused with a micron, which is a millionth of a meter. Okay, in order to transfer this building, I've had to take care of some fire code violations. 2 of my emergency fixtures were not working properly. This is one of the old ones, an older B50 unit from Bodine. As you can see, quite a lot of wiring. There's my new instant start ballast right here. So a lot of work to do, a lot of wiring. That's what we got to do. Okay, and this is my high reach apparatus going up there to do that light fixture, change out that emergency ballast. I go to that platform and then up to the next. Okay, we are up top now, and nice view from up here. Okay, now there's our nice new emergency ballast, Bodine B50, and I have it wired. As you can see, quite a bit of wiring between that and the instant start 4-bulb electronic starter. Okay, now once I connect these two together, this will make the inverter switch, and when I put 2 tubes in these 2 locations, they should light up before I turn AC power on. I just want to see if the battery pack is in good order and that the emergency ballast is working in emergency conditions. And then if that works, then I'll plug in AC power. And I have it wired for these 2 locations here. So hopefully, if the wiring's correct and I plug that in, I'll put 2 tubes in there and see what happens. Okay, very good. So our 2 tubes are lighting up pretty brightly. That means the factory battery was charged pretty nicely before it was shipped, and the storage was not too long. Okay, that's very good. The proper 2 came on that I wanted. So I'll take these tubes out, close this fixture up, and apply power to it. And there's a light on the side there that indicates that it's charging when I apply AC power. So we're almost finished here. And here's a 100 kVA transformer. We had to install that because we have this older section, one of 2 sections. That's the original building. It's 240 volts coming from underground, but we needed 480 in the room next door for several machines. So this transformer had to be installed in this room because the other room was too crowded. Nice lockout tag out, which I employ in every instance. 250 amp fuses are the largest fuses I have in the building. outside of the distribution centers. This facility has a very tightly controlled environmental system. Very important and necessary for CNC machining for accuracy purposes. We had to stay within about a 10-degree margin throughout the year. These Lux timers greatly assisted in that high accuracy level of environment. These things are really great. The beauty of this is that these are 7-day timers and go into a cool program, and you'll notice up here, Monday, day, evening. That's start time and stop for each quadrant. Okay, and then it goes to Tuesday. Again, now each quadrant has a default value, as you can see. In this case, Tuesday day starts at 8 a.m., but I can change that to start at 8:45 and end, let's see. Okay, it will end at 3 p.m. and I can adjust that too. We can back that up in this case. So, and then on to the next day, evening, and then Wednesday, and so forth. It will do all 7 days. So I can really tightly control 7 days all day long, and then turn them off later in the day. As you can see, they're greatly maneuverable, and these are omnipresent throughout the facility.